Okay, I was interrupted. Somebody came into my office, and I'm going to continue on where I left off. I had substituted my first solution, my first dependent portion of the solution, into the first row. This is row 1. And I was in the process of subtracting that 107 from both sides and using my calculator to make sure that I don't make a mathematical error at this point, because I know it's negative 30. Okay. So what I have now is x is 2z minus 30. So I know that z has to be greater than or equal to 0 to be viable for the rest of the functions. So now I'm going to find out part A, which is the total number of solutions possible. Hey, remember we set it equal to or greater than 0, the identity of z. So I can start with my x equals minus 30. And I can say 2z minus 30 has to be greater than or equal to 0. 2z has to be greater than or equal to 30. Z must be greater than or equal to 15. All right, so I've got that x has to be greater than or equal to 15. So now I'm going to do the y. Y equals 107 minus 3z. So I'm going to set the 107 minus 3z greater than or equal to 0. I'm going to subtract the 107. Divide by 3. Sorry, there we go. So I'm going to say if I divide by a negative, it flips the symbol. So I'm going to have a negative 107 divided by a negative 3. And therefore, z has to be less than or equal to. And if I do that math, I'm going to get a decimal, but I want to know what it's going to be. So it's going to be a positive 107 divided by the 3. And I get 34 and 6 over, right? So now, what happens here? Well, I can now state that I can include the 35, maybe, or not include the 35, depending on how we visualize what we have. But for sure, we can have, it has to be greater than 15, but less than 34. And I'm not going to include the 35. So now I'm going to subtract them and add 1, right? Subtract and add 1 because I include the 15. All right, so let me do that. So I'm going to get 20 if I include that. So it's 20 possible answers. All right. So now that I know how many possible answers I have, the B one says, find the solution with the smallest number of $5 bills. All right. Smallest of the $5 bills. So that would make it 0. So 0 would be the smallest number of $5 bills. So how would I do that? Well, I know the lowest value of z is 15. So if we have x equals 0, then I have to put in 15 for y. I do my 107 minus the 45, and I get 62. Because this would be what we would have. We would have 0 for bills of 5, because that's the lowest, 62 bills of the dollars, and the 15 of the 20 to give us that $920. So then they want the largest number of items for the value. And that would make it, well, what do we have? Well, we know that our largest number of fives would depend on the lowest number of, or the highest number of 20s, right? Okay, so what would we have then? Well, we would drop in, so that would be, because a C is the one I'm looking at now. Well, we would want to reduce the number of everything else that we would have in order to make that occur. So, what would the math be for that? We would have 20 as Z. So that we would have the highest number, that was 20 possible answers. So we'd have 20. And then we would have for our X, let's see, 2Z minus 30. It should be, should have 40. Should have 40. Sorry about that. Let me look at this. Not 20. I would do the 30, the 35. Okay. 5. That's the highest number. I don't know why I said 20. I think I was just messing up on that. Z has to equal that 35 because it's right over the edge. And we wouldn't have 34 even and work it that way. So then I would have my X equal 2Z. What's my X? 2 minus 30. So X would equal 70 minus 30. X is, I'd have 40. My Y would equal, what was my Y? 107 minus 3 times, and I would have the 35, wouldn't I? That would give me Y one, yes. That would give me 107 minus 3 times the 35. That would give me 2. Of course, my Z would be my largest, 35. And there you have it, guys. Thank you so much for listening. Now do the homework.